Welcome to the GATE video. I am Julia Faith, working as an assistant professor in IT department from S.A. Engineering College. Today we are going to discuss about the topic called searching. Now let's see what is called searching and what are the importance of searching. Here, searching is an algorithm which is very important in computer science, which will be acting as an important tool for finding the elements with a collection of data. The main task of searching in computer science is it is used to retrieve the data and also it is used to locate the elements. It is mainly used to solve problems in artificial intelligence. There are two types of searching process. First one is a linear search and second one is binary search. We'll see what is linear search. Linear search is nothing but a searching process which will do a searching in a sequential manner. We'll see how it works. Linear search here checks each element one by one. So this will be checking the element one by one in a sequential order until the target is found or the end of the list is reached. Here, this linear search works on sorted data or unsorted data. Meaning for sorted or unsorted data is we will be having certain elements and those elements will be arranged in an order. If it is arranged in an order, it is called as sorted data or it is called as unsorted data. So here the algorithm, it says that we have to start from the first element for doing the searching in linear search. And then we have to compare each element with the target element. If the particular match has been found, then we can return the index value. If not, we have to continue with the same procedure. Means we have to move to the next element, and if the match is found, we can return the index value. If the match is not found, again we have to move to the third element by increasing the index value. So this is the process of linear search algorithm. We'll see an example for linear search algorithm. In this, we have to search the key 47. Here, they have given an array of elements. In this, there are 8 elements given in the array. The array starts from the index value 0 to 7. And here the elements are 34, 10, 66, 27, 47, 8, 55 and 78. In this, the elements are given in unsorted manner. In linear search, we can able to do searching in both the process. One is we can do searching in sorted data or we can do searching in unsorted data also. So here we'll see how the searching works in unsorted data. In step 1, we have to first start the searching from the index value 0. So the index value 0 has the element 34. Now we have to compare the value which is in the position 0 with the value with the key value we are going to search. The value we are going to search is 47. The value which is present in the 0th index is 34. Now we have to do a comparison between 34 and 47. Here 34 is not equal to 47. So we have to move to the next element. Means we have to move to the next index value. The next index value is 1. Now the pointer shows the index value as 1. This one contains the element 10. Now we have to compare the value 10 with the search key. The search key is 47. Now we have to compare or we have to do whether the matching is correct or not. Here 10 is not equal to 47. So what we have to do is we have to again move to the next index value. By this way we have to do the process. Now we have moved to the third index value. The third index value is 2, which contains the element 66. Here the value 66 is again checked with the search key value. The search key is 47. Here 66 is not equal to 47. So we have to move to the next iteration. The next iteration is the next index value is 3, which contains the element 27. Here 27 has to be checked with the search key. The search key is 47. Here 27 is not equal to 47. So again we have to move to the next index value. In step 5, we have moved to the index value 4, and this index value 4 contains the value called 47, and the search element we are going to do is 47. So here the index value 4 contains the element 47, and the value which we are going to search is also 47. So here the match has been found. So 47 equal to 47. So now what we have to return is, we have to return the index value for the matched answer. So the index value here is 4. Now the element which is found at the position is 4th index. So that's it about linear searching process. Now we are going to see what is called a binary search. As the name indicates, binary search, here we have to divide the array elements. We have to make the array elements into two halves. Means first we have to divide, and then we have to work on the process. This binary search works on only sorted array. Means it will work only on sorted elements. So here we have to divide the array elements into two halves, and then we have to find the target value, or we have to find the optimal answer in the logarithmic time. The algorithm says that first we have to find the middle element. We have to divide the array, and then we have to find the middle element. If the target equal to middle, then our process is over. If not, if the target is less than the middle value, we have to do the searching process on the left half. If else, what we have to do is, we have to move on the right hand side, and then we have to move to the right of, and then we have to do a searching process. So this is the algorithm for binary searching. We'll see an example for binary search. Here we have to do a searching with a key element called 31. Here it contains of 10 elements with the index value 0 to 9. All the elements are in an sorted order, because binary search works only in sorted elements. So all the elements are given in sorted order, like 10, 14, 19, 26, 27, 31, 33, 35, 42 and 44. Now as per the algorithm, we have to first find the mid value for this array element. So the mid value can be found using the formula called mid equal to low plus high minus low divided by 2. For this we have to take the index value. So start of the index value is considered as low. So the start of the index value is 0 plus high means end of the index value. The end of the index value is 9. So what we have to do is, we have to take the low value as 0 and high value as 9. So low plus high minus low, that is 0 plus 9 minus 0. So 9 minus 0 is 9, plus the low value here is 0. So 0 plus 9 divided by 2. So the answer is 4.5. So approximately we have to take only the integer value. The integer value is 4. So 4 will be considered as the mid of the array. So now the index 4 has been chosen here. So this will be considered as the mid of the array for this binary searching. So in this binary searching, now at the index 4, we have to compare the value. The search key value is 31. So this 31 has to be checked with the index value 4. The index value 4 has the element 27. So 27 has to be checked with the searching key 31. So here the 31 value is greater than the index value. So what we have to do is, we have to move to the upper half of the portion. Means we have to move to the right hand side. So the right hand side consists of the elements 31, 33, 35, 42 and 44. Here we have to skip the left portion. Means the left half should be skipped, because the value is greater than the search key. So we have skipped the left portion. Again, for this portion, we have to find the mid value. In binary searching process, we have to continuously or repeatedly find the mid value until the target element is found. So for this element, we have to find the mid value again. So the mid value can be find out using the formula low equal to mid plus 1. Already we found that the low value is 0. Already we have found that the mid value is 4. So now we have to find the low value, that is mid plus 1. So 4 plus 1 is 5. Now the low value will be considered as 5. Again, we have to use the formula for finding the mid of the array element. So the mid of the array element can be found by using low plus high divided by 2. So the low value is 5 and the high value is 9. So 5 plus 9 is 14. 14 divided by 2 is 7. So now it shows the index value as 7. 7 contains the element 35, and this 35 should be compared with the key which we are going to search. So the value we are going to search is 31. So 31 is lesser than the index value, 7 positions, a value called 35. So what we have to do is we have to move to the left hand side. We have to skip the right hand side because the values are greater than the index position. So we have to move to the left hand side. The left hand side consists of two elements. One is 35 and another one is 33, and the third one is 31. So now again for this one we have to find the mid value. Again the mid value has been found. Here the mid value found is 5. So now the fifth index consists of the value called 31. This 31 should be compared with the search key value. The search key is also 31. So here a correct match has been found in the position 5. So now we have to return the index value as 5 with the searching process. It shows that here binary search divides the searchable items, and thus it reduces the count of comparisons to be made to very less numbers. So here it returns the target value 31 is stored at the location 5. So that's it about binary searching. Now we'll see the time complexities of both the algorithm called linear search and binary search. So the time complexity of linear search and binary search is given in terms of best case, average case and worst case. These are the advantages and applications of linear search and binary searching. So we'll see the advantages first. First one is we can able to retrieve the data in a quick manner. Second one, it improves the system performance. And third one is it makes us to take the decisions easier. And next one is it is scalable for large number of data sets. And the last one is it is mainly used as the foundation for many algorithms. So these are the advantages of searching. Now we'll see what are the applications of searching. The applications are searching process can be used in a database, and also it is mainly used in compilers for doing symbol lookup process. It is mainly used in games for path findings, and next one is it is mainly used for recognizing the patterns, and also it is mainly used in search engines. These are the gate questions which will be asked. So the first question is, which of the following is best represents the time complexity of a binary search algorithm in the worst case? Here they have given 4 options, and the option is correct answer is B. The answer is order of log of n is the time complexity, is the best time complexity of binary search algorithm. In the second question, they have asked about a linear searching process. Here, in linear search, the best case occurs when The options given are key is at the middle of the array. Option B is key is at the last position. Option C, key is at the first position. And the last one is key is not in the array. In linear search, as we discussed in the algorithm, the first step says that we have to start the searching process at the first element. So the answer for this one is the key should be at the first position. So the option is C. The third question, they have given a problem here. They have given an array. The array A consists of 6 elements. The elements are 5, 3, 8, 4, 2 and 7. We have to find the key 4 and we have to return the index value at which position the value 4 is present. So for this, first we have to write the index value for the array elements. So 5 will have the index value 0, 3 will have the index value 1 and 8 will have the index value 2 and 4 will have the index value 3, 2 will have the index value 3 and 7 will have the index value 5. So here in this, the correct key is found at the position called option D. The position is 3. So 0 is 5, 1 is 3, 2 is 8 and index 3 has the value 4. So the correct match is found at the position 3. Now we'll see the fourth question. In binary search, how is the search space reduced in each step? The options given are option A is by half, option B is by one element, option C is by 1/3, option D is by doubling. As the name indicates binary search, and also we have discussed how the search space gets reduced. As the name indicates binary search, here the array elements gets divided into two halves. So the answer is by half. So answer is option A, that is by half. Now we'll move on to the fifth question. Binary search can be applied only if the data is option A, random order, option B, sorted order, option C, reverse order, and in option D, tree form. So binary search will work only in sorted order, means the array element should be in an arranged manner. So the answer is option B, sorted order. Thank you. Meet you all in the next video.